Hello, hello, hello. Can you hear me?
Hello, sir.
Hello.
Hello. Yes, I can hear you.
Okay. So, how are you all?
I'm fine.
Okay, so you okay. So basically, today is our sixth number of class. So mainly today I will try to discuss about the land use land cover classification from beginners to advanced part using the Google Earth Engine platform. So how we can easily perform the land use land cover classification using this Google Earth Engine platform, and any types of classification. It can be crop classification or different types classification. We'll also try to discuss. Okay, so let's go. So I simply share my screen. Now, can you see my screen?
Yes, sir.
Uh,
Yes, doctor.
So hi and welcome to the 7 days online training program on Google Earth Engine for remote sensing analysis from beginners to advanced level. So basically, today is our sixth number of class, and mainly today we will try to discuss about that land use land cover classification, how we can easily perform the land use land cover classification using the Google Earth Engine platform. So mainly today I also try to discuss about that how we can easily make the land use land cover classification map using machine learning. So there are a lot of machine learning will be available in Google Earth Engine platform, such as random forest, then classification and regression trees, then support vector machine. Okay, how you can easily use this type of machine learning method and how you can easily perform the land use land cover classification map, and then how we can easily make the land use land cover classification chart. In the chart we can calculate it, the area, as well as we can also make the accuracy assessment. What is the accuracy assessment of this land use land cover classification map? This type of analysis we try to discuss. Then how we can easily calculating the land use land cover classification area, how to add the legend on your land use land cover classification map. Okay, and lot of things we will try to discuss in when I want to go to the land use land cover classification. So basically, when you want to make the land use land cover classification, uh, always it follow the some process, and this process is the same when you want to make any types of classification. Always we follow the same process. Suppose you want to make the land use land cover classification map, you want to make the crop classification map, you want to make for any types of other classification map, just follow the same process and you can easily make this any type of classification map. So first step is that you have to select your region of interest. Suppose you want to make the land use land cover classification map for Dhaka city, so this Dhaka city is your region. Suppose you want to make the land use land cover classification map for whole country boundary of Iraq, so this is your region of interest. So first of all you have to selecting your region of interest. So mainly we can just upload our shapefile boundary. When you want to selecting your region of interest, I want to work with the Dhaka city, so just I simply import the Dhaka city boundary shapefile. I want to work with suppose Iraq, then I can simply import the Iraq boundary. Okay, so which area you want to need, simply import this boundary shapefile. And we already covered the part how we can easily import the boundary shapefile. Then second step, you need to choose and filter your image collection. So in this time, if you want, you can use here the Sentinel image. If you want, you can also use here Landsat image. And we already covered the part how we can easily filtering the Landsat image, as well as how we can easily filtering the Sentinel image. Okay, just you have to filter your specific image collection. So mainly Landsat image is 30-meter resolution, and Sentinel image for the 12-meter resolution. Okay, Landsat image we can get for the long time period satellite image, and Sentinel image we can get the short time period from year up 2015. But Landsat we can get from year up to 1973. from this time period. Okay, and then after that you need to collecting the training point, and in this time there are a lot of way for collecting the training point. If you want, you can go to the field and take the training point. Suppose mainly when you want to work for the crop classification, different types of crop classification, then we can go to the field of the crop, and from this ground we can take the training point as a, suppose this is the mustard, this is the maize, this is the rice, this is the vegetable. So different field we can collect some training point for different crop when I want to make the crop classification. So you can simply go to this field and take the GPS location. Okay, and then we in this GPS location combine of the latitude and longitude, then we can simply convert this GPS location as a point shape file in Google Earth Engine platform. Then from this point shape file we use for extracting the band pixel value. Okay, or if you want, you can also take the training point from satellite images. Suppose from this satellite images we can easily identify this is the build-up area, this is the vegetation, this is the water body, this is the barren land. We can take the training point from this satellite image also and make this classification. After that you need to merge all of the training point. Suppose you take the training point for water body, build-up area, vegetation, cropland, then you need to merge all of the training point together. So this is the fourth step. After that you need to make a training data set by using all of those training point. In this time, this training dataset means that in this time we extract some band pixel value from these satellite images, and this band pixel value, suppose for water I collect some band pixel value, for vegetation I collect some band pixel value, for build-up area I collect some band pixel value. Okay, so all of those are data set, and this data set I need to use for further analysis. This data set I need to use for train my model, as well as also use this data set for test my model. So when I want to make the training data set, this data set I divide it into two portions. So first, some data I use for train my model, and some data I also use for test my model. What's the accuracy of my model for checking this? Suppose I want to use 70% data for train my model and 30% data for test my accuracy, or 80%, 20%, different ratio we can use, and we can easily divide the data set. Some data set we use for train our model, and some data set we use for check our model or test our model. Okay. After that, when I want to train my model, I need some classifier. Okay, so mainly this classifier is different types of classifier is available in Google Earth Engine platform, such as classification and regression trees, then support vector machine, then minimum distance. Okay, so this training data set I need to create this classifier and add this all of the training data and classify the image. Okay, and create the classified image, and after that display the result, and also need to print the confusion matrix. So in this time I also use for the testing data. This testing data I also compare with my classification result and create the confusion matrix, and from this confusion matrix I can easily calculate it, the overall accuracy, then kappa coefficient, then producer accuracy, then consumer accuracy. So all of the accuracy we can easily calculate from the confusion matrix. After that we can calculate the area for each classes. Okay, so basically this is all of the process when you want to make any types of land use land cover classification map. Just follow this all of the process and make. It can be crop classification, it can be land use normal land use land cover classification. Okay, So basically, this type of classification called the supervised classification. Okay, this supervised classification, we just make the level data. So we already put the level data input. Suppose I want to put this is the water, this is the build up area. So this is the category categorized, already categorized. So that's why it's called the supervised classification. I supervise this classification and create this land use land cover classification map. Okay. So now all of the things we just write, I will show you practically. Then I hope you can easily understand all of the things step by step. So I simply open my code editor. Try to show you the part. So I can simply open a code editor. Okay. So now, first of all, I need to import my boundary area. So in this time, I want to create this land use land cover classification map. Suppose a specific region of, suppose Dhaka city. For this boundary, I want to make this classification. So I simply import. I want to display this result and then just focus the center of this shape file. Object is ry, zoom level suppose 10, and click to the run. So now you can see this is my area. So this is my first step. I simply select my region of interest. Okay. Then second step, I need to choosing and filtering the image collection. So in this time, suppose I want to use here, suppose Sentinel 2 surface reflectance satellite image I want to use. So mainly land use land cover classification we are using here for surface reflectance or SR images. When you want to use the Landsat, you use here the Landsat surface reflectance. When you use here the Sentinel, you use here the Sentinel surface reflectance. Okay. So just I simply click on the browse data catalog and click on the Sentinel. And now I want to use here Sentinel 2. From Sentinel 2, I select surface reflectance. You can see this is surface reflectance. So in this time, I use the surface reflectance image and then try to make this classification. So here you can see, here I can get all of the information about this image collection, such as also band, image properties, term of use, all of the things I can get in here. Okay. So in this time, first of all, I need to import this image collection in my code editor. Just simply copy. I put a variable name, suppose Sentinel SR, and put this image collection. So now my full image collection is stored in a variable. Okay. Now this full image collection, I need to filter according to my region, according to the specific time period, according to the image metadata. Okay. Just we filter. Take a variable, suppose image, and you can see this is the image collection. This image collection is stored in a variable. I simply call this variable, copy and paste in here. And first of all, use here the filter bounds function. And filter bounds function mainly it intersecting with your region of interest on your full image collection. So in this time my ROI, and then put here this filter. Okay. So in this time I want to create this image collection for year of 2020. Suppose 1st January from 2020 December 31. This time period I want to filter need the satellite images, and then I also use here the filter, is here the art engine filter less than. I put here the less than, go to the image properties, such as less than, suppose 1% cloud pixel. You copy and paste here the 1%. After that, I want to check how many images I want to get. So I simply print function use and call this image and click run. So in this time, it print the result how many images are available for my region which are less than 1% cloud cover. I can get total 27 images for this region which are less than 1% cloud cover and which are available the year of 2020. Okay. So in this time, if you want, you can work with for the single image. Suppose you want to work for the single image. Suppose you want to work for this image, which image the capture year of 2020, 17 January. You want to work with this image. Just simply use and copy this ID and paste the image in here. Okay. So we already covered the part. So in this time, I want to create all of the images median composite. So for that, I can simply use the median function, median, and it clip with my shapefile is that ROI. Okay. So now I display this result. F.add here, add the image, click to run. So now we display the result. You can see. Okay, so you can say I can get the image look like this. So in this time, I need to add here the visualization. So for that, simply click on here, and you can use here. You can see I want to use here the red band before, then green band, and finally blue band, and increase the straight 98% and apply. So now it added this visualization. You can see we can get this satellite images look like this. Okay. And also import this visualization parameter in here. Simply copy this name and paste after the object name. In this time, object is the image. I paste after the object name and also put the layer name. Suppose true color. Okay, so now it's set with my code. So here I can get this image collection. Okay, you can say I can get the clear image. Now this is my second step. So you can see we can select our ROI, choosing Sentinel surface reflectance image and filtering this image. Okay. Now third, collecting the training point. So in this time, we can use here this training point from these satellite images. Okay. These satellite images, I want to collect some training point and then make the classification. So in this time, I want to collect the training point for field of area, then water body, then vegetation, then barren land. Okay, so this type of class I want to classify. So for that, I need to collect the some training point from this satellite images. So when you want to collect the training point, it's very easy way. Just simply click, you can see marker, add a marker, then click the edit layer properties and put this. Suppose I want to take the training point for water. Just simply put here the water, then import as feature collection property. So I put the property name can be anything. There is no specific name or any constant name. You can use any name, but property name will be same for all of the class. Okay, so I put the property, suppose class, and set the value for water is 0. Okay, so in this time I take all of the training points of water body, this value will be 0. Okay, so then okay, so now I can easily find out this is the water body. I take the training point for the water body. So just I simply take, also this is the water body from here. You can also get the some water body, river, you can. And when you want to take the training point, there is no any limitation. Okay, so we take the training point and also check the accuracy. Suppose I did not get the mass better accuracy, then I need to also increasing my training point. Okay, so there is no limitation for that. But for the when you want to work with for the big region, try to take the training point more than 50. It's also better. Okay, but we need to check the accuracy. If we get the accuracy is the low, then we need to also increasing the training point for getting the better accuracy or make the better land use land cover classification map. And when you want to take the training point, there are a lot of way for taking the training point. We can use here the lot of band combination from here, and we can easily identify the different types of feature from these satellite images. Okay, so in this time it's B4 red, green, and blue. It's called the RGB, or also called the true color composite. So mainly true color composite, it showing the result what human eye can see. So in this time, naturally, we can get the natural color. You can see naturally, this is the water body. You can easily identify this type of color vegetation. You can easily identify. This is the build-up area. You can see build-up area. We can easily identify. Okay. So natural color, we can, when I use this band combination. Suppose I use here the another band combination, such as I use here the, suppose, short wave infrared 1. This is the B11 short wave infrared 1. Then near infrared and blue. Then custom 98% and apply. So now you can see I can get this image look like this. Mainly this, in this time we can get the brown color. You can see this type of brown, this type of color, it's identified as a barren land. Okay, this is the barren land, and this is the vegetation. Okay, this type of color, and water body will be black color or dark. You can see water body dark. So when I use this band combination, basically different types of band combination we are using to identify the different types of feature. Okay, so when I use this band combination, I can easily find out the barren land. You can see this is the brown color barren land, water body as a this type of dark color or black color. Okay, and vegetation will be this type of color. We can easily find out this vegetation. Okay, so we are using here the different types of band combination and take the different types of feature. So mainly band combination will help you to get the feature. Okay, so in this time we can, when I use this band combination, I can easily identify the, you can see this is the barren land, this is the vegetation. Okay, so there are a lot of band combination we can easily apply in here and identify different types of band combination. Suppose you can simply go to this link, see for the suppose then set band combination. I simply select in Google, search in Google, and you can see from this link you can also get the better idea about that band combination. So mainly you can see this is the 432 for Lancet, 432 band for Lancet. 4 is the red, then 3 is that green, and 2 is the blue. When I use this band combination, I can get the natural color. When I use the 543, 543, 5 is the near infrared, 4 is the red, and 3 is the green for the Lancet. Okay, but when I apply the Sentinel, then this band number will be different. Suppose I want to apply this band combination. So first of all, near infrared. For the Lancet Sentinel, near infrared will be B8. Okay, then you can see the red. For the Sentinel, red will be B4. Okay, B4. Okay, I check this. Red, okay, red is that B4. Okay, you can see near infrared is that B8. And then also green. So green is that B3. Okay, for the Sentinel. Apply. So now I can get this composite look, image look like this. You can see in this time the red, this red color, it's identify the vegetation. Okay, dense red color identify the dense vegetation. You can see this is the vegetation. Okay, this type of color is the vegetation. Okay, so you also try to read this link I also send you. So you also try to read, then I hope you can easily identify the band combination, and different types of band combination will be help you identify the different types of feature easily. So you can see this type of band combination. Okay, also you can see when you want to identify the barren land and or agricultural land, then we can use here this type of band combination. Okay, so you can see short of infrared one, then near infrared and blue. You can simply set this band in here, then we can easily identify this feature and take the training point from the satellite images. Okay, so this is the process when you want to take the training point from the satellite images. So in this time I take the water. Okay, then I also take the suppose vegetation. Simply click on here and put here this geometry name, suppose vegetation, and feature collection property will be same class, and set the value 1. Okay, so in this time all of the vegetation training point, this value will be 1. Okay, so in this time you can see I use this band combination, near infrared, then red and green, then I can easily find out the dense vegetation. You can see, so I take this training point from here, dense vegetation. Also you can see this is the dense vegetation, so you can simply take this training point from this red color, dense red color. Suppose this is the vegetation, also this is the vegetation, 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 vegetation. You can also use here the another, suppose I want to use here the short red one, then I use here the B4 red and B3 and apply. Sorry, it will be near infrared, B8, and then it will be blue, B2, apply. So now I can get this vegetation look like this. You can see, so I have to take this vegetation. Now I easily identify better. You can see this is the vegetation, green color. Okay. Vegetation, vegetation. Okay, so you're using different types of band combination to identify the different types of feature. Okay, done. So in this time I take the new layer and click on here. In this time I take this training point for the barren land or fallow land. So barren land, and put the feature collection property will be same for class, and set the value for 0, 1 and 2, then okay. So you can see when I use this band combination, we can easily find out this barren land, this type of brown color. So just I simply take this training point for them from here as a brown color pixel value. this is the wetland. Okay, so you can see this is the sparse color of brown. Okay, so this is the wetland. Okay, if you want, you can also make the other class for the wetland. Then you can use that the new layer for the wetland and also take this. Then this time I also use that the same class also including with the parent land also including this. Okay, so that's why this time I'll not take the another layer. But if you want, you also identify the wetland. Then you can see this is the barren land, but in this time this color is the sparse. Okay, and then feature collection property will be same for class and set the value for 0 1 2 3. Okay, then okay, so you can see first 0, then 1, then 2, then 3. Okay, so now look at the natural color. Then you can either the 4 red, then green and blue. Apply. Then you can easily identify the lot of build up area. Okay, again. Okay, so now I take the scanning point from the build up area. So for that I already put this. Click on here, build up. Now you can see it will look like the bold black color font. Then I think it will use a lot of build up area. Okay, I take this training from the build up area. Okay. In this time, I take the training point for you can see the water, vegetation, barren land, and build up area. I take this training point, and you can see all of the training point also added in here for the build up area, barren land, vegetation, and water. Okay. So in this time, I move to our next process, merging. Okay. In this time, you have to merge all of the training point together. So for that, we can simply use that this take a variable. Suppose the sample. This variable, I stored all of them merged. So first of all, you can see water, user the water, and user the merge function, merge with it, and it also the training point. I want to print what the result I can get here. Function and of variable name one and print this and click run. So in this time I can get how many training points I can get. So here you can see, here I total 320 training point get for all of this training point, total 320. Okay, I merge and store in a variable sample. In this time you can see, so all of the training point, and all of the training point has also including their class. You can see this is the class 1, and class 1 is for vegetation. You can see 1. So all of the training point, you can see this training point class 3. What is the class 3? Class 3 is that 0, 1, 2, 3 build up. Okay, so in this time all of the training point already know about their class. So that's why it's called the supervised classification. So I already put their value, I already labeled this data. So that's why it's called the supervised classification. And now I need to extract the band value. So I need to extract the band value for all of this training point. So all of the total 320, all of the training point, extracting the band value. So in this time, I need to select some band value from here. You can see B1. I need to select B2, B3, B4, B5, B6, B7, B5, 6, B7, 8. Okay, then B8A. Okay, can use that the B11 and B12. Okay, so now I simply take a variable. So put the variable name, suppose band. This variable, I just make a list. So make the list and put B1, B2, and B. Four, 5. I just simply select all of the band. So in this time, here all of the total 320 training point from the band pixel value from all of those bands. Suppose the point, this is the point for the class, so is that water, and this is the point, the value. So for this point, what's the value for all of those bands to start? Same, all of the total 320 training point, extracting all of the band value. Okay. Now I will be extracting all of the band value from and then the set function and set all of the band. First variable print all of the band. I use a function called sample region. This function helps you extracting the band pixel value. Sample, yeah, please.
Excuse me.
Yeah, please.
Your sound is not clear.
Okay, so okay, now can you hear me?
Yes, I hear you now.
Okay, okay, right. Now I just simply use that the sample region function, and then I can all of the arguments. I make a dictionary Hello.
Sir, you are not audible, sir.
I'm here, but I don't hear you, Mr. Rahman.
Can you hear me now?
It's a lot of noises coming, sir.
There is noise in your sound.